When it's above, it is
positive, and when it's at the bottom, it's negative.
there we go.
Yeah.
Should we move on to the end?
So
That's it. That's it. We've just done that. We've just done signed area in 20 seconds. Basically, when it's above, it's positive. When it's below it, negative. Just did it. There we go. Done that whole chapter. So just let me just show you a couple of things though. So when you get this, if it says find the area of the shaded region, if you get a negative value, so if you and you know yourself, if you're finding the area of something underneath, you might get an area, you might get an integral of -2. But if they've asked you for the area, what should you say afterwards? The area is 2. Yeah, because you can't get a negative. That's why I call it an absolute area. So you see the little bit different, Shelby? You're right, but I call it exactly the same thing. Again, this one. Don't worry, I'm going to do some questions. Don't freak out. Yeah.
Just to check if the area is above the line, just stick a minus on it.
No, if the area is above the line, it's positive. If it's below the line, it's negative. And oh yeah, so sorry, you can stick a negative. So if it's a minus and you want it to be an area, we can't have negative areas, so what do we do to it? Make it positive, yeah. That's why I call it absolute area. Remember the absolute sign? What does absolutes do to negatives? Make them positive.
So this is absolute area.
Yeah.
okay, so when you talk about like positives and negatives, even something like that little triangle that kind of goes into the negative area of the x-axis, is that still considered positive?
Yeah, that's an area, yeah.
Alright.
So let's do a few, let's just get our head around it, shall we? Now, they give you lots of rules here.
You just buy it.
I would probably just use common sense instead of these, but they are very good rules. It's like all the rules for everything, it just gets very confusing. So I'm going to miss some of these out. And again, because we played in the play box, we played in the sandpit, what have we already done? We've already done it. See why playing can be quicker? You were far more efficient when you were younger, playing around with it.
So
And you guys are far more efficient than the older people because you play around with it.
so for the signed area, is it the both of them added up, or is it the positive?
Alright, so if they ask for the area, it's the absolute of each bit added up. So let's go right back to that one we just did. You know, that when it was like that, yeah? That was -4, and that was 4. But without even thinking about it, Mikhail, what did you tell me the area was?
It was 8.
8. But if you want to do it we're going to do it mathematically in a minute, don't worry, we'll definitely do it. It's the absolute of that, 4, that's the absolute of that, 4. It's just a bit more mathematical. Yeah? Same thing. Let's do it. Okay. And these are actually, they're quite interesting actually. I'll show you these because I think they are useful and some of you will use them. In fact, I don't use them as much, but I think you might. So don't worry if you don't like them, they're useful. And I'll draw some little pictures as well while I'm doing it. So what they're saying, if you go from A to B, so imagine, I'm just going to do a very poor graph. If I go from A to B like that and get an area or an integral, it's just like doing this. It's just like going from A to C and then plussing C to B. So you can split this up if you want. And again, it's just visual. A lot of you will do this accidentally. If you try and find the area over just one point, what's the area going to be? If you go just from A to A, from the same point to the same point, and you'll do that accidentally. Nothing, so be careful. If you get nothing, that's fine. You probably put 2 instead of -2. That's what normally happens. You would just type a typo. This one's a useful one as well, and you've learned this through integration. Remember, what can we always do with the constants with differentiation and integration? We can pull it out. We just ignore it. It's like this one. If I said to you, again, you don't even think about it. If I said to you, the integral of 2x squared dx, you just leave the 2 as a constant, add 1 to the power, divide by the new power. That's what it's telling you to do. The constant can come on the outside. This one's a really, really useful one as well. If you're adding 2 separate, and I'll do an example, a proper example with you, but you can actually add 2 separate functions together by using integration. We'll do an example of that, that's what it's saying. And this is probably one of my favourite ones, and I think that's what you were trying to say, Mikhail. What you can do is if you do a function from A to B, you'll get one answer, but if you swap the values and go from B to A, what will you get? The negative of that answer. Just place, because you've got, because again, imagine it's like if I go back to this one, Go back to what we were doing before. It's like if I swapped, or not a good example of x is 0, because 0 is the same in either way, but it's like this one. If I swap 2 and 0 over, instead of it being that minus that, it would be 4 minus 8, so what would it be?
Negative.
Negative, so if you swap it over, it makes it negative. And it's useful to know that because, again, it'll probably be an accident if you've done that. It stops you misunderstand what you've done. So sometimes, and Jazz did it without realising you did it the wrong way around when you were playing on your calculator. It just made it a minus. It wasn't a big deal. It was just the other way around. Just realise it's just a value. Okay. All right. So, I'm not going to do those.
Could you do one of question 11?
Yes, I would love to do question 11. I was just going to ask you straight in there. One of those?
Yeah.
Yes, definitely. These are the best ones to do. And I know, actually, well, I'll jump straight to the hard one. That's probably the best way of doing it. You might not get this straight away because I'm jumping straight to the hard one. You're not stupid if you don't get it. Which one would you like to do?
C.
C? Cool. Oops, let's try again. Actually, I'll just do it underneath. So 11C, yeah? Now, these are the ones that they'll give you. Just a quick one. Most of the ones we've done so far have been simple, familiar. What makes this a little bit more complex? What do you need to do? Expand it and do what? So what's going to make this easier? Remember I told you a little bit ago. So is there a visualization of this at the moment? What would make it easier? Draw it. That's what's making it harder, really. It's a classic one. When I was looking at Pimber, I looked at hundreds of these papers. That was the trick that they were doing, and they're going to use that in the external. So if they show the picture, it's simple. If they don't, it's not.
Would this be calculated?
Could be either. Great question. The reason why it could be either is they're nice numbers. You know what I mean? You know, if it was calculator, use it.
Yeah.
I'm probably the world's worst example for that, because I probably wouldn't use it, because I prefer not to use a calculator, but use it. Let's do it without a calculator first. So we do it both ways, without a calculator? Sure. So let's do C. So let's do it as TF. What does that stand for? Tech free. I don't know why they would say non-calculator, but anyway. Because tech free is not even using a pen, to be quite honest. So tech free. We've got to find the area bounded by the x-axis and the graph. So the x-axis, so first thing we've got to do is draw it, haven't we? We really have. So to draw something, we have y equals, you can put fx if you want to, by the way. What's the first thing we do? We're going to draw something, always. Memories, what do we do? Always, 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 always. We find intercepts, yeah, intercepts. Find x and y intercepts, yeah. So let's do x-intercept at y equals 0. These are the two tricky ones, like I said. I don't know why my computer's being slow, I'm sorry, but it's really messy. So you got that. Then we're going to have x plus 2 equals 0, or 7 minus x equals 0. This is the null factor law. So you don't have to actually state the null factor law as long as you state that bit. Don't jump straight to the answer though. So you either have to write this or null factor law, one or the other. Don't jump, it's going to stuff you up if you do. Alright? Are you happy with those two?
Yeah.
Cool. And what's the y-intercept going to be? Y-intercept on what? X equals 0. So it should always be just, that's nice. Yeah? So we get y equals 2 times 7. So what's the y-intercept going to be? 42. I hope I did that right. This is a very high answer. I think it's right, isn't it? Okay. Now, another thing that you might not have spotted, is it going to be a happy face or sad face? It seems ridiculous to talk about this. Let's talk about year 9 stuff, but this is where it is, it's year 9. Is it happy or sad? So it's definitely an x squared, isn't it? But is it a happy x squared or a sad x squared? And why? There's various reasons why.
Well, it would be a sad one.
Why?
Well, because, well, this is just how I worked it out in my head, but if you do, using null factor law, the x is minus 2 and 7, so if you just do a value between there, the easiest one being 0.
That's good, I didn't think of that.
Positives.
Yeah, it's a good idea. So it's just, so what Shell told you about, I do 2 different points of view, so let's see if it's positive. Great way. Yeah. I just know as well that just x times negative x is negative x squared. It doesn't matter, does it? As long as you don't just guess, use your common sense. Now, if you draw it, I keep forgetting how to put lines on here. Where's lines on here? I'm so bad. No, where is it? Can I do lines on this one? I've still got the old one up here. There we go. There we go. Mr. Bradley can do advanced integration, but can't use one now. Go figure. So what do we have to put on here? Really important. Yeah. Now, even though you're probably not going to get any marks for this, always have high standards. It takes seconds, and then if there are random marks available, or if there are actually marks it says to draw it, you're going to get all the marks. So let's put in what's going to happen. So it's going to cut at -2, isn't it? Yes. It's also going to cut at what? 7. I know I'm doing this to scale. You don't have to. Don't worry. And then it's going to be cutting y at what? 14 was it? Yes?
Yep.
Now I've missed. I'm not going to lose marks. Okay, that's my special bit. Okay? So it's fine. I'm going to keep doing it. I don't want to just do it nice and relaxed. Happy with that? I know.
Do you know what the top is like for the...
Oh, I can find that. Yeah, good question. And if we were asked for that, we could find that. There's a little trick, 2 tricks actually. While we're on there. Because it's symmetrical.
Yeah.
What's in between -2 and 7? What's the average of -2? 5 and then half it. So what's going to be halfway in between? Yeah. Stick 2.5 into that equation, and I'll get the top. And there's also another way using b minus b over 2a, but that's probably the easiest one. Yeah. Good question. It's coming all that stuff from year 9, isn't it? Yeah. For this one, I don't think I have to care about that, but yeah, good question. So you can find that really easy. And make sure you do those kind of things with you, but especially when you're not. Whether I've told you you must do things under exam conditions, but when you're playing with the question, just add some little extra. Because if you don't want to lose them argument, it says, oh, and part C is find the maximum point in your game. There's another way of finding the maximum point now. It's when the differential is 0. I forgot you can do that now. Yeah, that's because I've been teaching some year 10s as well. Yeah, there's different ways of finding them. Alright, so, and we're going to practice a lot more, by the way, in Unit 4. A lot more about changes, etc., etc. So, what do we do now? Let's read the question again. Because what you do, you've forgotten what the question is. Find the area bounded by the x-axis in the graph. So if you'd actually said the y-axis in the graph, that'd be different once it's a different area. Are you happy that's the x-axis in the graph? Definitely? Yeah. Okay. So what we're going to do to find the x-axis in the graph, we're just going to do what? We're going to do loads and loads of little trapezoidal rules? No. Because he didn't tell you to do that. I'm going to tell you. What's going to be the easiest way to do it? Integrate. Yeah. So it's the integral between -2 and 7. And then write this down. Now, I know why. I was going to say I don't know why this is a complex one. No.
Do you need to because why not be a negative area?
Will it calculate a negative area? Let's go. While we're talking about it, let's actually put. Let's switch. Let's play the sandpit. Let's actually put it on here. So, good question. Yeah, let's play the sandpit. Instead of thinking that, let's just put it on here. So, what was it? X plus what? X plus 2 was it?
Yeah.
Yeah. Multiplied by 7 minus X. Yeah. Cool. And then if you draw it, don't panic if it goes out a bit like that. You can still do zoom out if you want, or you can change your window size. Again, be honest, does that bother you? If it bothers you, I'll show you how to change, or does it not bother you? Yes or no? No, remember, I think it's Mr. Bugatti loves things to be square. That just bothers him, so it's just whatever bothers you. I'm then going to go, and oops, I'm going to do this, because I'm rushing, I'm going to do that, so let's take time, Mr. Bradley. We're now going to go G-solve. We're going to go over, so I'm doing it in my head. We're going to find the integral from what? -2 was it, yes? Yeah. To 7. And that's given us that, 121.5. Cool, is it? And remember, if it's a calculator one, you won't get as many points. So please do it on the calculator. You're just wasting time if you draw it from the calculator. Yeah? They'll be sneaky if it's a calculator one, they'll do those negative ones to catch you out on the calculator one. Happy with that? So, let's go back. What was your question by the way, Mikhail? I know I
answered.
Yeah, has it answered it?
Yeah.
Yeah, so what we do now? Now this is a bit harder. Now I know there's a couple of specialist mathematicians in here, because I teach a couple of you. Do you do specialist maths as well?
I did not.
You don't know, okay, that's good. So if you don't do specialist maths, it's not an issue. If you do specialist maths, you will be given a thing called integration by parts. Don't use it, specialist maths people. how can we integrate? We haven't got a method, because I haven't taught you the method of integrating things at a time
Is
together.
there an actual way to do like a...
Yes, and if you do specialists, you're going to learn it and you're going to waste time, because when I was doing this one with a couple of my specialist mathematicians in specialist other group, they were trying to do it the hard way basically. There's an easier way. What are you going to do with that? Expand it, yeah, just expand it. Now whatever you do though, don't expand it and change the brackets, because what you're telling me you're doing if you change the brackets, you're telling me you've done what to it? You have differentiate, you've integrated it, yeah? You're absolutely correct, you should be able to differentiation, but I'm going to be naughty and say integrate. So we've got that, multiply out x minus 2x plus 7x plus 40. Have I stuffed that up?
I think it's a negative x squared.
If I stuffed it. Oh yeah, I have. Ooh, silly was about that. Let's do it properly. I stuffed that up big time, didn't I? Let's go through it logically. First, negative x squared inside 14. Yeah? Plus 7x minus what? 2x. Do you see how I stuffed that up? I tried to rush it out. Really easy to stuff it up if you rush it. That was a very silly mistake on my part. So it's going to be negative x squared plus 5x plus 14. Are you all happy with that? Yeah, well done. See how I stuffed that up there, Josh? I was so careful with it. So what's going to happen is specialist mathematicians will overcomplicate that by trying to use something called integration by parts, and I stuffed that up by just not using FOIL. Use FOIL, just multiply out. Okay. So, got 7 and 2. So it's still negative x cubed over 3 plus 5x squared over 2 plus what? Well then, Shelby, I can see you're very pleased with yourself. So you want to nail it. No, I can tell. Oh, no, what is it? Plus what? 14. X. There you go. Now, you could probably tell me now, what's that more likely to be in? Calculator or non-calculator? Yeah, I could do that. I'm going to stop. Yeah? And blah, 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 blah. Have a go at it. It's good for your brain. What's it going to be?
Something.
Something. What's the something going to be then?
I don't know.
121 points?
Something.
No. 121.5 units squared. How do I know that? That's what I've got to do it on calculator. Would it be a good idea for you guys to actually put that into your calculator and work it out? Yes. It really won't hurt you. Alright? It really, really won't hurt you. There you go. That wasn't that bad, was it? For a complex familiar. Sometimes easier than some of the unit 1 and 2.
So why is it that it wasn't complex?
Great question. The reason why is because we didn't draw the picture. And because you had to multiply it out. 2 reasons why actually. Because you had to multiply it out to integrate it.
You need to expand it
Yeah.
before you could. Yeah.
And to be honest, it probably wouldn't be a complex familiar on the tech active. Why not?
Because you can grow.
Yeah. So it probably, and I think it'd be fair enough. So I'd be just simple familiar. Yeah.
Would you make that on tech 3 a complex familiar?
Yes.
You would.
Yeah, definitely. It's an easy complex familiar. Maybe I'm easy, but it should be. It's like anything. I was talking to Sasha and you guys were grabbing a drink. Anything's easy, isn't it, if you work at it? Did I tell you, I don't think I told you the story, I told my year 12. My son started year 12, didn't do very well. His last maths exam he got 100%. Because he started studying and working. You're the opposite, you're my hard working group. You can get 100% by actually pulling back on some of the study. You've got to do the opposite with you and studying smarter. You know what I mean? It's easy for people who don't work as hard, they just have to work harder. A little bit harder for you guys. You need to work with me. So I need to get your parents in, and we all need to work as a team so you don't burn yourselves out. Because that's the most dangerous thing can happen with year 12, because it can be a little bit intense. Okay? Right. Let's zoom on. I know it's a lot. What time is it? 12:40 with you guys?
Yeah,
12:40. No, that's why I'm recording it. It's a lot for me as well. Might just show the video of me to the other people.
What did you say the answer was?
Oh, sorry, right. Yeah, let's do it. I can't remember what I said. 121.5?
Yeah, okay, cool.
Yeah.
Yeah.
I'm getting worried. Is that right?
Yeah, that's what I
Okay.
got.
Let's have a look as well. Joking aside though, where else can we check? We can check with each other. Where else can you check at home as well? What else is on here where we can check? Work solutions. Nothing wrong with that. If it's not the same, use the thing and email me. So what was it? C?
11C.
11C. That's it.
1 8
Yeah.
10C.
The answers are pretty good on here, you know, overall. Let's just yeah, some people say, why didn't you put them separately this time? It takes forever to put them separately, guys. Come on, give me a break. I worked through them all for you. What was it, 11 what? 121.5?
Yeah.
That's it. Okay? There you go.
Mr. Bradley, this is jumping a little bit back.
Doesn't matter. Just go.
This question, the one where we had like the positive and the negative bit.
Let me just find it. That one?
Yeah.
Yep.
So with that, I was thinking it's in the scenario that it's not exactly the same as the positive one.
Yes. Good question.
Could we use the not area method to determine, because that came out as 0,
Yes.
to determine that they are equal?
No, again, that's a great question. So imagine, I'll just draw one like this and show you. In fact, should we even do one, if we had a real weird and wonderful one like a quartic or something like that, yes? You know, which looks a little bit horrible. But the trouble with the quartic, that bit is not equal to that bit.
Yeah.
So what we could do, best thing to do on this, and I'll show you a couple too, is to do from there to there and find that area. To do from there to there to find that area which is a negative, and then the positives together. That's the easiest. I probably should have explained it more. It's only just because it's a nice one of those curves that they are actually symmetrical.
So is it just because like that's a cubic, isn't it?
Yes, because it's symmetrical.
So then you know that you can't just go 4 plus.
Yeah, and I should have explained that to you. The safest thing to do is to do that area plus that area, and I should have said that.
But if you can really determine that they're the same, then
You're
can't
fine.
be more
Yes.
efficient and
And that's why the complex unfamiliar comes, because they will ask you that question and say, why can you do that?
yeah.
Yeah, well, just forget, if you really have that little doubt, it doesn't take long to do it. Yeah, but yeah, you're right. It's one of those ones that really, really is hard to, that's why I want to get application. That's why the more we do of these, you'll actually see some of those examples, because they will catch you out.
Yeah.
Yeah, but that's a great question. Be careful. Some people go, well, you said they were similar. I went, I probably should have said, like, today, I should have made it very clear it might not be the same. You might have inferred that. You see what I mean? They could be different sizes, they could be. Okay, right. Remember, and I know some of you, and I know you think I'm not being sympathetic with it. These are the basic antiderivatives. I know you don't like me saying they're basic. When you get to university, they'll actually call it elementary.
Oh.
Elementary means rock hard in code. So you'll do elementary engineering, elementary this. It means it's rock hard, basically. But you need to know these. And the big thing goes, remember I've talked to you guys, use your time efficiently. So instead of spending ages revising, spend 1 hour doing as many of these as possible. And you're going to get a lot wrong because you put yourself under pressure. Then go back and practice. That's what I want to see from you. I don't want to see from you 4 hours worth of revision, because that's just going to make your head want to explode. We've got to get used to doing it under pressure. And it's going to be far more useful if Melly comes to me and says, I did this under half an hour conditions, look at all these mistakes, because then I can find out what mistakes she makes. Okay? So be careful. Already some of your parents are dropping you in that you've been doing too much work. Okay. Alright. This is where a few of you had to ask me questions who've been working ahead. Because it's the same method, but unfortunately now, what have we got to remember our rules for? Oh, say things like I could say to you, what is sine of 90 degrees?
Pi over 2. 2 pi over 2.
Oh, got 4 or 5 as answers. Oh, that's what happens every time. That's good. Let's do it. So let's go. Don't feel bad. Remember, only to have fun with this. When we say it's a dumb mistake, it's not you being dumb, okay? It's not. So, am I in degrees or radians at the moment? Have a look. Radians. So I can't say. So I've got to say pi over what? Pi over 2. Yeah. Shift pi over 2. You can change it to. You're welcome to change it to degrees.
Oh, right, yeah.
And there you go.
That's just the question.
Sine pi over 2 is 1.
Cool.
But if it's a tech free, this is the difference. My son's year group from last year could have done cheaty, just looked on the calculator. You guys need to know this. I'm more than happy to do a unit circle lesson a little bit later. I'm going to show you how powerful that unit circle is. It really is powerful. Okay, I know everything from imagining that unit circle. What's sine 0 going to be? Doesn't matter if you get it wrong. What sign is 0? 0. Jazz, what sign of pi radians?
Sine of pi.
Pi radians.
0.
So
Sine of pi.
Sign of pi.
Yes. 0.
Why?
Because it's the equivalent of.
Yeah, well done. See straight away how she's doing a picture? Yeah? Straight away you get like that. You've got to do it like that, and that's what maths is about. It's very visual. What about sine of 270 or sine of 3 pi over 2?
That's
Nearly. It's not up, it's down, so it's not a negative one. See how we're visualising it? Yeah. And you've got to be careful about this. Don't listen to the tutor. We've got some really good tutors from last year and the year before. They're going to go, oh, we could use a calculator for that. That's nice. Just tell them, just to really put them on the spot. Do you think they'll be able to do that from memory? No, they're getting paid good money to work here. Go. So find those right tutors. Go. What side of pi? What's that? Panic them. That's what they're going to have to go and do. They don't study. They're teaching you in the new system. You don't want to hear stories about the old system. You want them to tutor you in the new system. Same with your tutors. I know you've got some superb tutors. You don't want to know that you could do. I wasn't allowed to use a calculator. It's fine. It means it's easier. It saves me going to a calculator. You know, I'm lazy and I don't bother using my calculator, do I? You notice that? I've got to use my calculator. It just seems like an extra thing. So let's do a few. Remember, you are guns now at integration. It's just going to be the integration remembering that's going to get you. So which one shall I do? Should we do a sine or cos? I don't mind. Which one would you like to do? Just choose one.
one of each.
One of each. Should we do one? Yeah. So should we do 10? So
10F.
10F. Okay. Yeah. Okay. That's fine.
That's a guy.
It's a bit of a yike.
I didn't know we
We
could.
might as well do a yike because it's actually not as yikey. You're actually going to do the same mistakes with a yikey one as a non-yikey one. So, cos 3 theta plus. Make sure you write it down first. That's the biggest yike people do. Because I remember when I'm marking stuff, I'm going, how come they've done this perfectly but not got the right answer? They've written the question down wrong. And that's the way to zero. And in the old system, yeah, you're fine. In the new system, that's wrong. You can't write the question down wrong. It's wrong. Right. You won't get many. Just make sure you don't do it. Okay, this one. So what we're going to do though, first thing we're going to do, we're going to integrate it. I'm going to show we're going to integrate it. We're going to do that, aren't we?
Yeah.
We're going to move this over. We're not going to ask Mr. Badley because it's a long-winded conversation about why that happens. We can look up on YouTube if you want to. So we do that. This is telling us we're integrating. Oh, we've got to remember this now. It's all from last term.
Cos becomes sine.
Well done. Divided by 3. Now this is where it's a little bit more of a yike.
What?
Cos integrates into sine, but remember when you're integrating, you're doing the opposite of differentiation. And because it's not just theta, it's what theta? 3 theta. So you don't times by the differential, you divide by the differential. What's the differential of 3 theta? 3. And so you go, whoa. Yeah, this is a whoa. Don't worry.
That's
Okay. I'll still just.
This is the yike one.
Yeah, right.
While you're processing, I'm just going to move over to show you a couple while you're processing. So, you watch, just watch. Let's do this one. If I do this one, let's do a non-yike one. What does sine theta?
Cos.
Cos.
There you go.
Yeah, well done. What does, now let's make it a little bit more of a yike. Sine goes to cos.
Oh, 3 cos.
Yeah, remember that? I'll show you why. I know it's not on your formula sheet, but if it's sine of a function, you are welcome, by the way, to use the chain rule. I know a lot of you don't like the chain rule. Remember the basic call when we did the chain rule? Yeah. So, it's always this. Sine goes to cos, and you multiply by the what? The differential. Look, I know this looks like EI, but I'm just doing the opposite. Maths is opposite. Cos went to sine. What's the opposite of multiplying by the differential? Dividing. It's not as much as a yike, is it? It's a little bit of a yike. Now, this one. What does sine integrate into? Negative cos. Divide by 3. Good. Now, this is why I never dismiss 0. Remember, next to the group, actually, the group said, why do you write 0 then? Because what's cos of 0? 1. So don't dismiss 0. It's a really dangerous thing to do. So let's put all this in. So we put in sine 3 times pi over 3 over 3 minus cos 3 times pi over 3 over 3 divided by sine 0, 3 minus cos 0. Happy with that?
Is there any way of making that reversible?
Yes. I'll tell you something. Remember, I don't like the way you guys do divide by a half. I don't even like that step because of my head. I'd actually miss this step out. I would go straight to 3 times a third is sine pi over 3 minus 3 times a third. If you can't do that in one go, it's fine. Do 2 steps. Just because it scares me, Tube's doing this, not me. There you go. Now, unless you've got the world's biggest spy plan and you've got this calculator you've smuggled in, this is almost definitely going to be non-calculator.
Why is it?
Because we're mean, basically.
Oh, sorry.
Well, why is it?
Sorry, I thought you said it was calculator.
No, and like I said, unless you're a spy and manage to smuggle one in, this is definitely a non-calculator. If you do smuggle one in, by the way, you are out of that exam. Alright? There's no failing out of the exam. So please don't accidentally, if you accidentally bring it in, give it in to somebody. Good news though, in the internals, remember a couple of them, you can't get in trouble in the internals. It's actually a trust thing. I'll tell you. Sorry?
So we can cheat those.
No, but I can tell if you're cheating, you'll lose loads of marks. Yeah, and if you're warned, that can get recorded, so don't. Yeah. Guess what the best way of cheating is? Revise. Learn it all. Yeah, not as the most moral way. The best way is to revise and get better than everybody. That's the best way of cheating. That's cheating. Better. Yeah? Yeah? But I have you guys say it all the time. You guys say to me, oh, blah blah gets the highest marks because they're smarter. No, they don't. They get because they work harder. That's the way. That's the cheating bit. You can all do it. So, what's sine of pi?
Sorry.
What's sine of pi? Yeah.
0.
0. Good. What's cos of pi?
-1.
-1 or -1?
-1.
Look, see, remember, if I draw a unit circle, it's here. It's based on how long you are horizontally, so it's definitely negative. I'll see you can stuff that one up. What's sine of 0? 0. Good. What's cos of 0? 1. Now see how this could get messy if you're not careful? Negative a third is a third. Negative third is a third. A third plus a third is?
Units.
Okay, have fun with this. Genuinely have fun. I'm actually really